In this set of class notes, we're going to continue our work with circles. We're going to look at some problems, though, that are probably a little more on the challenging end than what we saw in the video notes. So in this first one, it says to find the equation of the circle with endpoints of a diameter that are at -1, 1 and 5, 9. So, a good principle is, whenever in doubt, draw a picture. So let's go ahead and sketch where these 2 points are. All right, make some tick marks. So 1, 2, 3, 4, 6, 7, 8, 9, 10. Okay, probably good enough there. So we know that these points are at -1, 1, so that puts me right there, and 5, 9. So 1, 2, 3, 4, 5, up 9, about there. All right, and so we know that that right there forms a diameter. That's what it told us. All right, so you can visualize our circle. It's going to be something like this. Okay, so great. Now let's think about what we need to do, right, in order to find the equation. We know that the equation of a circle looks like this, right, where HK is the center and R equals the radius. So if we can just come up with the center and the radius, then we've got our equation. All right, so let's maybe start with the radius here. They've given us these 2 points that are on either end of the diameter. And of course, we know how the radius relates to the diameter, right? The radius is exactly half of the diameter. So we should probably turn our attention to figuring out what is the diameter of this circle. Okay, so can I figure out what this distance is? Well, the answer is sure I can, because there's a couple ways to look at it, I suppose, but one way to look at it is I could form a right triangle, and anytime you form a right triangle, you can use the Pythagorean theorem, right? So we know that the distance from here to here is 6, and we know the distance from there to there, let's see, that's a y value of 1 to y value of 9, so that would be 8. And so one way to approach this would be to say, okay, if this is d, then d squared equals 8 squared plus 6 squared, which is 64 plus 36, which means d squared is 100, which means d equals 10. All right, so we know d equals 10, and so therefore our radius has to be 5. So that's good. So we know that we can stick a 5 into that part of our equation. Now, just as a little aside here, some of you may have been looking at these 2 points that we had and wondering, okay, I know in the past I've used the distance formula. And of course, the distance formula is really the same thing as using the Pythagorean theorem. But if you happen to just remember it as the distance formula, what you could have said was d is the square root of the difference in x values. So that would be 5 minus -1 squared plus the difference in y values squared. And of course, you can see that gives you the exact same thing, right? 6 squared plus 8 squared, which of course still gives you 10. So if you were kind of thinking of things more along the lines of the distance formula, it's the same thing as the Pythagorean theorem, but it's just kind of a more formulaic way of remembering it. All right, so what about the center? Well, the nice thing about a center is it's got to be halfway through that diameter. And so thinking about halfway between the point -1, 1 and the point 5, 9 means that I just have to find the midpoint of the x and the y. So in other words, go halfway between the x's, so that'd be 3 over here, and halfway between the y's, so that'd be up 4. And put me right there. So that means that that right there has to be the center, which certainly looks like it's at the point 2, 5. Okay, now you say, okay, well, what if it wasn't so obvious to me, or what if it wasn't as easy to see based on my picture? And of course, that's perfectly valid. So how would we do this more formulaically? Well, finding the midpoint of two numbers is just you basically averaging them. So another way to approach this would be to say that the center is the average, so add up the two x values and divide by 2, and then add up the two y values and divide by 2, right? That's what's going to give you the midpoint of that line segment. And so, of course, that gives you 2, 5, just like we just discussed. So to put all this together, we know the center, we know the radius, and so therefore our equation is going to be x minus 2 squared plus y minus 5 squared is equal to 25, right? Because remember, that's equal to r squared. So there is our equation for this circle. Now what's going to happen at times is you're going to be asked to come up with information about a circle, and it's not going to be presented to you in terms of the equation in that standard form that we looked at on the last page. So here's one that actually happens to be a circle, but in order for us to be able to figure out what is its center and what is its radius, I really need to get it into that familiar form of x minus h squared plus y minus k squared is equal to r squared. All right. So what we need to do here is take a look at this and see if it reminds us of anything. So when I say x minus h quantity squared, y minus k quantity squared, that might make you think of when we completed the square earlier in the quarter, right? Remember, we completed the square when it came to putting a quadratic function in vertex form, right? We learned how to do that. So here what we can do is we can kind of gather our x's together, gather our y terms together, and then see if we can do some completing of the square. So step number 1 is to say x squared plus 4x, and then I would have you remember that when you complete the square, you add some amount, right, in order to do that. Okay, so I'm going to add, I'm going to put this in black here. I'm just going to leave a little blank space. And then we'll go ahead and put our y's together, plus y squared minus 6y plus, and I'm going to add another blank. I'm going to use a different color for this one, red. And you'll notice that we've got everything accounted for except for this 12. Okay, but I'm going to go ahead and move that 12 to the other side. So it'll be negative 12. But then, of course, if I'm adding stuff to the left side here, I better add that same stuff to the right side. So we'll say plus the black empty space and plus the red one. Right? And so I can add whatever I want on the left side as long as I add that same stuff on the right side. All right, so what do we add? Well, remember that what we do is we cut that middle term in half, and then we square it. Right? We cut the middle term in half, and then we square it. And so that is what we're going to put over here. So on this side, it ends up being x squared plus 4x, and then you have 2 squared, which is 4, and then y squared minus 6y, and then this is negative 3 squared, which is 9. So negative 12 plus 4 plus 9. But the whole purpose of that is so this can collapse down into x plus 2 times itself, and this can collapse down into y minus 3 times itself, and then putting all this together gives you 1. So just from that right there, what we can see is, don't get tripped up here. Remember, x plus 2, that means that negative 2 is the x value of the center, and then positive 3 is the y value of the center. And remember, why is that again? Because the form is x minus h squared, right? Y minus k squared equals r squared. So you're subtracting the x value of the center. So this is subtracting negative 2 to make plus 2. So there's our center. And then our radius, right, of course, is just 1 in this case. All right, and then similar question on number 3 here. I think it'd be a great idea if you tried this one, since we just did one together, and this is a similar one. So go ahead and give this one a shot. All right, so coming back here, right? X's together, but you know what? There's only one x, right? And then y's together, and I'm going to want to add something equals, I'm going to move that 2 over to the right side and then add that same something. Now notice, the reason that I haven't put any blanks after the x squared is because it's already a perfect square, right? If you've got no x terms, you're already in good shape. So x squared just goes along for the ride, but what are we doing? We're going to add half of the middle term squared, or the middle coefficient squared, on both sides. So this is y squared plus 10y plus 25 equals negative 2 plus 25. So we still have x squared, and then this would factor into y plus 5 squared. Foil that back out, you'll get these 3 terms right here. And that equals 23. All right, so what's my center? Well, this, right, if I really wanted to, you could rewrite it as this, x minus 0 squared. So the x value of the center is just 0. And then, of course, the y value is negative 5. And then remember that this is r squared. So when we say what is the radius, we should be saying it's the square root of 23. All right, let's take a look at one last one here. And again, I would encourage you to pause the video and try this one yourself. You'll have to dig back into some of the skills that you learned when putting quadratics in vertex form. But go ahead and give this one a shot, and then this one also wants you to graph it when you're finished. Okay, so let's start by working on the form of this thing. So we have 3x squared plus 6x. So we'll put those x's together, plus 3y squared minus y is equal to 0. Okay, now let's remember that when we complete the square, we don't really like to have a number, a coefficient other than 1 in front of our square term, right? So back when we were working with putting quadratics in vertex form, we would factor out any kind of leading coefficient. So let's do that here. So we're going to take out the 3, and that allows this to become x squared plus 2x plus y squared. And then you might kind of object to factoring out a 3 because you say, well, 3 is not a factor of this term, but we take it out anyway, right? Remember, we did that back when we were working with quadratics. So take it out no matter what, whatever it takes to get a 1 in front of the square term. So then you say, okay, what do I multiply by 3 by, excuse me, to make -1, well, you'd multiply it by -1/3, right? And then, of course, this 3 that's out here, since there's a 0 on the other side, you can always just get rid of it. If you divide by 3, that's no problem. And so what we have here is x squared plus 2x, and I'm anticipating that I'm going to want to add something. So we'll go ahead and put a red blank there. And then we'll add something else, put that one in green. That still equals 0. All right, so what do we put? Right, we're putting half of the middle coefficient squared, and then half of this middle coefficient squared. So remember, that would be half of -1/3 would be -1/6 squared, right? Half of a third, right? So that's what we're going to add to both sides. So over on the right-hand side here, for that red and green blank that I forgot to write, 2/2 squared, -1/6 squared. Okay, so on this left side, x squared plus 2x plus 1 plus y squared minus 1/3 y, and then this is going to be plus 1/36, right? And that's equal to 1 plus 1/36. So we know, right, this factors into x plus 1 times itself. And then this one factors into, and with all these fractions, it might be harder to generate this right off the bat, but remember, whatever you put here has to be the square root of this. So that would be 1/6. And I know it's negative because the middle term's negative. And then, of course, over here we can, get common denominators. So this is x plus 1 squared plus y minus 1/6 squared is equal to 37/36. So the radius here is the square root of 37/36, and that's pretty much 1, just about 1.01. And then our center is -1/1/6. So I can go up here, find -1/1/6 on this grid, and understand that since my radius is about 1, that means that I really, I don't want to go -1, -2. I don't want to like stick real close here. I want to give myself some space to actually graph this thing. So I'm going to go ahead and, put -1 there, -2 there. And similarly, we'll go ahead and, put 1 here, 2 there, -1 there, -2 there. All right, so we know that we are at -1/1/6. So, maybe this is about where 1/6 is, right? If that's 1 and that's 2. So here's our center. And then we're supposed to go out 1.01 in any direction from the center. So, if I go out here just barely past -2, just barely past 0, right? Just barely past 1 1/6, so maybe right about there. And then this would go down to -5/6, right? And that would be my circle. Now, what's always a good idea is to have a good understanding of intercepts, right? So as I go to graph this, knowing where it crosses the x-axis might be a good idea. So let's do that. So x-intercepts, right? That's where you set y equal to 0 and solve for x. All right, this is something we do all the time. I don't know why it says solver for x, but we'll fix that. So if we're putting 0 in for y, that term and that term go away. And so we just have 3x squared plus 6x equals 0. We can factor out a 3x. So we get two possibilities here, x equals 0, x equals -2. And that certainly seems right, that I'm crossing here and I'm crossing here, right? And then if I wanted to do the y-intercept, that's where we set x equal to 0 and solve for y. And of course, we can kind of guess at what this is going to be. This will probably be, my guess would be at 1/3, right? Because if we should have this symmetry, because clearly 0 is a y-intercept, and so that same distance from 1/6 that I am below it, I should be above it. But let's just do the algebra. So this time, getting rid of the x's, so we have 3y squared minus y equals 0. And so I can factor out a y, so that's 3y minus 1 equals 0. So of course, yes, there's y equals 0, which we already knew. And then 3y minus 1, so y equals 1/3, just like we guessed. And so it's going to cross right there. All right, and so now we can go ahead and make a quick sketch of this thing. And there we go. And I can, now that I got a kind of light outline in there, we can go ahead and do a little bit better job. And there is our circle.